In this lecture, we're going to learn about move-only types. And these are types in which the copy constructor and the copy assignment operator are not usable. And it is what I describe here. Let's look at a simple example here. We have our box container class. If we go in and delete our copy constructor and delete our copy assignment operator, our box container class is going to become a move-only type. And what that means is that you can't use copy constructors with this type. You can't use the copy assignment operator because they are deleted now. If you try to use them, you're going to get a compiler error. Now, some of you must be asking, why would I want to limit my class in such a way? Well, sometimes the design forces you to do things this way. A good example is the unique pointer class we have learned about previously in the course. You can only have a single unique pointer pointing to a piece of memory in your C++ program. Because it is a unique pointer, you can't have more pointers pointing to that same location. So following that design, you should enforce that you can't really copy that unique pointer to have another pointer pointing to the same location. And that's a good example of why you might need to have move-only types in your C++ program. Now that you understand the idea, let's head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is move-only types. We are going to reuse the code from the last lecture, so let's grab everything from there. And we're going to copy that, put that in our current project, and open this little boy in our Visual Studio Code editor by dragging and dropping here. So we will have our class here. And what we want to do is to delete our copy constructor and our copy assignment operator. What we want to do is to mark them as deleted. So what we do here, let's mark them as deleted like this. We can say delete. And the copy constructor will be deleted from this point on. We can go down and find our copy assignment operator. We can also delete it using the delete syntax here. And once we delete them, we shouldn't really have implementations for these. So we can go down and find our copy constructor. I think it is down here. We don't want its implementation in place, so we're going to remove this. And we can find our copy assignment operator and also delete it because we don't want it available in our class here. So we have our copy assignment operator right here. We can comment it out. Let's go all the way to the top and comment it out. And at the moment we do this, this class is going to become a move-only type. You can't copy objects of box container, and if you try to do that, you will get a compiler error. So let's go down in main and try to play with this. We have our code in place. I don't think we really need to change this a lot. But what we want to see is what happens if we try to copy construct box objects. So we're going to go in here and remove the std move thing. We're going to just try and copy construct from box 1. And at the moment we do that, you see that we get a squiggly line. And this is a good sign that this is going to blow up. This is going to give us a compiler error. We have no business doing this. Or we have no business copy constructing box container objects because box container is a move-only type. It is a move-only type because the copy constructor and the copy assignment operators are deleted. We can't use them in our C++ program. Let's try and build and show you the compiler error. We're going to pass this through our favorite compiler, which is GCC. The build is going to finish with errors. And we have a pair of nested comments here. So let's take this out because this is going to confuse our compiler. Now, if we take this out, this entire thing is going to become a comment for our copy assignment operator. Let's try and build and see if we get the error we were expecting. Now we will see that we have a use of a deleted function, and this is what I expected. This is now not giving us the error we had here as a result of a nested block comment we had. Sorry for that if it was confusing to you. Now the problem is that we are trying to copy construct box objects, but we shouldn't really be able to do that because box container again is a move-only type. It is a move only type because the copy constructor and the copy assignment operator are deleted. You see the copy constructor here is deleted. If we go down, the copy assignment here is deleted. We have no business copy constructing or copy assigning box container objects. If we try to do that, things will blow up. Let's try and set up another example to show that we can't also use the copy assignment operator. We're going to set up an empty box2 object. I think we can do this. And then we're going to go down and say, we try and assign box1 to box2. Again, this is going to blow up because the copy assignment operator is deleted. We have no business using it. So let's try and build and show you the compiler error. Let's pass this through GCC. The build is going to finish with errors, and we will see that use of deleted function, and the deleted function is the copy assignment operator. We have no business doing this because box container is a move only type. But if you try and move from box1, you're going to see that this is going to work. So let's try and say std move and try to do something like this. This will tell the compiler that we don't want to copy assign, we want to move assign, and this is going to build just fine because we have a move assignment operator in our C++ program here. Let's go down and show you that we have a move assignment operator, and this is going to work for the thing we are doing on line 21 here. Let's try and build the program. We're going to pass this through our compiler, which is GCC. Now you will see that the build is good because we are moving from box1, and a box container is a move only type, so we can move objects without a problem. And this is going to work really well. If we try and print box2, this is going to work just fine. We're going to see that in box2, we will have the data that we had in box1. And if we pass this through our compiler, again, this is going to tell us what we expect to see. The build is good, so we can clear and view our terminal window. And we can clear again and run Rooster. You're going to see that now in box2, we have the data we had in box1. And box1 is going to be a shell object at that point because we have stolen from it. We can print box1 again here. And to make things clear, we can put a separator in front of this line here. Let's use a bunch of hyphens. This is going to do. And if we build, we're going to pass this through our compiler. The build should be good as we see here. So let's clear and run Rooster. Now we see that after we do the stealing, box1 is going to become a shell object because we have stolen from it. And box2 is going to have the data we had in box1. And we are able to do this because box container is a move only type. We have a move constructor, we have a move assignment operator, so we can really move data without a problem. But if we try to copy, we will get a bunch of compiler errors as we have seen before. This is how you can use move only types. Now, we have used this with box container, but in the slides, I mentioned that std unique pointer was also a move only type. Let's try and play with that a little more. To be able to use a smart pointer, we will need the memory header, as you know. So let's bring that in. And we will go down and set up a unique pointer. Let's put in a separator again. And let's set up a simple unique pointer, which is going to be pointing to an integer in memory. So we use the syntax here. We create an std unique pointer to int. And the name for that pointer, or the name for that variable, is what we have here. And we dynamically allocate for memory using std make unique here. And the moment we do that, we will have this pointer here pointing to the memory location that contains this 33. Now, because this is a unique pointer, we can't have multiple pointers pointing to this same location because that's the basic design principle of a unique pointer. And if you try to have another pointer that points to this memory location, you will get a compiler error. Let's try and set that up. We can create another unique pointer, ptr, and it's going to be a pointer to int, ptr int copy. And if we try and copy assign from ptr int, we will see that we will get a squiggly line. This is a good sign that this is not going to work. But if we try to build, the build is going to finish with errors as you see here, and you see that we have the same problem we had with our box container if we tried to copy construct or copy assign. So we have a deleted copy assignment operator in std unique pointer, and we really have no business copy assigning between std unique pointer objects. If we try to do that, we will get a compiler error. But it is possible to steal from a ptrint here with std move. So we can say std move, and this is going to move ownership of this memory location to ptrint copy here, and ptrint is going to become a shell object as we have seen before. So let's go down and put in a pair of stdc out statements to really understand this. So we're going to say the data in ptrint. We're going to print this out, and we can just dereference the pointer. We can do something like this. And this is going to work just fine because we can dereference a unique pointer and print what is pointed to. Let's build and see that we can actually do this because we have this squiggly line. Maybe it is Visual Studio Code playing tricks with us. The build is good, so everything seems to be good. If we run Rooster, we will be able to print what is pointed to by our unique pointer. Let's try and steal from it using std move and try and print that again. So we can copy the code, go down here, and try to print it again. We can also try and print what we have in ptrint copy and see what we get. When you are learning, it is really good to try things out and see if your ideas hold straight. We can build again. We're going to pass this through our compiler. The build is going to be good, so we can clear and run Rooster, and we will see that we get a crash because we are trying to access data from a unique pointer object that we have stolen from. And this is going to blow up. We really have no business accessing this piece of memory. So if you know that you have stolen from an object, you should really be careful before you use it because you can't really be sure what is inside. Now, let's try and do a null pointer check on this thing. We can say fptrint. If it has some data inside, we will print what we have in. And else, if we don't have valid data inside, we can say that on the terminal. So ptrint. And if we build now, let's see what we get. The build is going to be passed through our compiler. The build is good. We can run Rooster. And now we see that our null pointer check is working. We know that we don't have any valid data in our pointer that we have stolen from. And this is really hopefully showing you that std unique pointer is a move only type because you can only move data between objects. But if you try to do row copies, you will get compiler errors because the copy constructor and the copy assignment operators are deleted by default. This is the design of unique pointer. This is all I had to share in this lecture. I hope you have a clear idea about move-only types. We are going to stop here in this lecture. In the next one, we will see that you can even use move semantics, not only for the copy constructor or the move assignment operator. You can use them on your own functions or methods, and we're going to explore that in the next lecture. Go ahead and finish up here and meet me there.